you do that one without even thinking anymore. But if you are going to take the derivative of x to the n, then that is x. So, oh my gosh, I don't even know how to write it. Bring down the exponent and then subtract 1. Right? The hard part, I think, is my brain does integrals and derivatives at the wrong time sometimes. I was just helping Sean with some test corrections, and I tried to do the derivative instead of the integral on one of his problems because I'm screwing up. But the product rule and the quotient rule, those are the ones I really want to make sure you remember. In 4th hour yesterday, I believe someone said, what's the product rule? That was me. I wasn't going to say it, but it was. But if you have two functions times each other, so we could just say like f of x times g of x. Remember that the product rule is you take the derivative of the first function times the second function plus the derivative of the second function times the first function. It doesn't matter which one you write first because you're adding, and it doesn't matter which one you write first in terms of the multiplying either, as long as you take the derivative of one times the other plus the derivative of the other one times the first one. And the quotient rule, on the no calculator multiple choice part, I know for sure there will be questions asking you to find the derivative using the power rule, the product rule, the quotient rule, and the chain rule. Because on that no calculator part of the test, they want to know that you know the basic rules. And so that's why I want to just make sure that you know these. The quotient rule would be if we're taking the derivative of two functions divided by each other. And remember that you don't always have to do the quotient rule. Sometimes you can divide it out. Sometimes you can bring it up and make it a negative exponent. But if you have a function divided by a function that you can't simplify, and I know there's one like that on the take-home test that you did over spring break because we did it in 4th hour already, but you take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the denominator squared. And remember I sang you that lovely song. I'm not going to sing it again, but low-de high, high-de low. I don't really think of that when I do this, but and I said you better bust your asymptote. I said that in it. About Mr. Love.
What did that have to do with Mr. Love?
That was part of the song.
Did you make it up?
And Miss Dobson. How do you have no memory of this?
I don't know that either. I don't think you sang it to us.
I did sing it to you.
I don't remember singing it. Sing it.
I'm not
Why
singing
does
it.
Seth always just randomly fall like this?
And the chain rule, that's the whole inside-outside function. If you're taking the derivative of a compound function, so like f of g of x, it could even be like f of g of h of x. Remember that this is where I talk about the M&Ms, which kind of is a terrible idea, but I get you M&Ms to eat on that day. But you have to take the derivative of the outside function first. You leave the inside alone, and then you keep taking the derivative of the inside function until there's nothing else to take the derivative of. But the way we write that is we say we take the derivative of the outside function, and you leave the inside function alone, times the derivative of the inside function. That's where all those u prime things come from. So when I ask you the derivative of ln and you say u prime over u, that's because that's the chain rule. Because the derivative of ln of x is 1 over x, but if it's something besides x, you have to multiply by u prime or by the inside function. That shows up all over the no calculator part. And so today, some of your homework is going to be just practicing doing that. Okay? So I have more handout for you. My favorite part of A through C is all the paper that I waste. Not waste. Gives you. I want you to make sure you're putting all this in someplace together, because after the AP exam, we are going to have a community burning party. Not really, we can't set it by here. But we have to throw it all away, because some of these things I'm not supposed to actually give you. You give it to me and I'll burn it on the weekend. No, you have to give it to me so I can see it.
Why?
Because I'm not supposed to give this stuff to you.
So we're not allowed, but what if I just set my whole binder on
What if I need this in college?
You don't need this in college. You can keep all your notes. You can't keep all your AP stuff.
What if I just burn it all?
I'm telling you. Every year I make them turn it in and they survive. You're not going to need it in college because you're going to get credit.
So when are you supposed to
The tests, the take-home tests that I give you,
Oh.
I'm not supposed to give you those.
Then why do they release them?
Well, I'm supposed to give them to you like in class as like an in-class test, but I'm not supposed to like give them to you to take with you because you could sell them.
Why can't we keep them?
Because
Like, why can't learn?
they're supposed to be secure documents, so like they're supposed to be like.
I was listening.
Just give them back to me. Is the answer.
Can we have notes?
Look, I put. Did you even read the jokes on the front?
Yeah.
You didn't even laugh.
Because you've given them to us before.
I've never given you those jokes before.
Yes, you have.
I've
I
given you
remember
every
the
joke.
bottom one and I remember the second one. I don't remember the one on the second one.
Not true. Not true at all. They're funny jokes. They're calculus jokes. This is just everything with derivatives today, pretty much. So there's a whole lot. I'm not going to spend forever on it, but these are what you're supposed to use tonight on your homework, and this is what you can use on your next take-home test if you forget this stuff. But the idea is maybe you won't forget it now, but you'll just have it in your brains. Finding tangent lines. Many people said they forgot how to do this, but remember that at a tangent line, you just need the slope, which is the derivative, and you need a point. That's all you need. So you find the derivative at the point, you find the y value to go with the x value if they don't give you the entire point, and you just write it. I wrote slope-intercept form or point slope form, and remember on a free response question, you do not have to simplify it, so my advice is leave it in point slope form. So we're just going to do one of these here to show you that finding a tangent line is not that hard to do. You just have to remember that the tangent line is, this derivative is the slope of the tangent line. So step one is you find your derivative, which would be 27x squared minus 2x plus 4. I don't know what I'm saying. I did 3 to the third power. 9x squared, I mean. And to find the slope, you just use the point that they give you. So I'm just going to find the derivative at -1. I'm just going to write here on this. Remember that that is your slope. And so that's just going to be 9 plus 2 plus 4, which is 15. And sometimes they give you the entire point, but oftentimes they just give you the x value. You need a point and a slope to write a linear equation. So the other thing that you need is you need to find the value at -1. So g prime of -1 gives you your slope. G of -1 gives you your y value. So that's plugging into the original problem. And you could do that first. Sometimes on a free response question, they give you a point just for finding one of those, even if you don't put it together. A lot of times it's just a 1-point question, but sometimes you can get 2 points out of this. If you plug -1 in here, you're going to get -3, -1, -4, -2. Is that right? 7, 8, 9, 10. So that's -10. So that's all you need to write an equation. You got a point, -1, -10. You have a slope of 15. And now you're just writing that in slope-intercept or point-slope form. Multiple choice questions, almost always they put them in slope-intercept form or maybe even standard form, and you have to match it up. But on a free response question, just write y minus y, which is going to make that y plus 10, equals your slope, and x minus x plus 1. That's it. That is a tangent line. Obviously, we could subtract the 10 over, we could simplify it, but on a free response, don't miss it because you do the math wrong. Like, just leave it like that.
There was one on the artistic exam though. Like they give us a graph or something, and I didn't.
I don't know. We'll have to find it and look at it. We're on the no. We're almost through the no calculator part in 4th hour, so we'll see what we find too. And then we'll look at it. What I want to start doing, and I know you guys are like anti-morning people, but I really, like, there's just not enough time in class to go through all those questions. Like, think about when we went over on Tuesday, we did 2 free response questions, and we took up, like, the entire period just to go over 2 free response questions. Those of you in 4th hour, we're going through stuff every day, and so you guys kind of have an advantage right now. But what I did last year with a newborn baby, I would come in at 7:40, and we would go over just the exams that we've taken, like just whatever we could get through between 7:40 and 8:10, every day, and I gave them extra credit points if they were here in their seat ready to go at 7:40 every day. Which, and so I'd like to start that, I don't know, maybe next week, if not the following week. If we started the week of the 14th, 1, 2, 3, that would give us 3 weeks and 3 days, mornings of doing that. So just keep that in mind. If no one shows up, then I'll stop doing it because, it's not worth it for me to teach to no one. As long as one person comes in, I'll do it. And that's a lot of days, which means you only get 1 point a day. But if we do that for like 17 days, that's 17 bonus points, which is ridiculous to give in calculus class. But what? That's on the test. No, if I take whatever, I told them, they're complaining about it, and I said the alternative is I make it out of 62 points. You're complaining! What do you call this?
This is not complaining. You said 17 is ridiculous. All I was saying was Caitlin got 190%. That is way more than 17.
17 is ridiculous to give you to just come in to learn, right? Like, I shouldn't have to bribe you with extra credit points to come in and get extra practice, is my thing. If you do so well and you earn extra credit, I'm okay giving you extra credit. I usually have multiple people that have A+ in calculus this 9 weeks, which is why I always say don't freak out if the report card you just got wasn't that great, because usually the next 9 weeks grades are a little overinflated because I give extra credit on the take-home test and I give extra credit for coming in early, and so usually this 9 weeks I feel is overinflated grades by the end of it. So, but anyway, just keep that in mind. I would like to start April 14th. We would meet every day except for that Friday because math team would meet that day, which means 3 of you would still meet that day. And then we'll figure it out from there. So just keep that in mind. Maybe start waking up like 2 minutes earlier every day until you get up to that point that by the 14th you can get here at 7:40.
I know all of a sudden now. Because they're one of the complaints about how it's early. The only person in this entire class.
That means I have to get
Just
up at
saying.
5. That's not.
I get up at 5 and I got up today.
That's not.
I work out.
Okay, normal line, I don't think that there's going to be normal line stuff on the AP exam just because I have the 2003 exam, the 2008 exam, the 2012 exam, and the 2013 exam. Of those 4 AP exams, there's never been a question talking about a normal line. They always talk about tangent lines. But I don't know what's going to be on there, so I like to remind you that if they ask you about a normal line, you know the tangent line, you know the normal line. The normal line is the line that's perpendicular to the tangent line. So you just have to remember what are the slopes of perpendicular lines. Opposite reciprocals. So in my previous one, what was my slope? Oh, this is going to not be so pretty. So if the slope is 15, then the slope of the normal line is the opposite reciprocal, which means I would do -1/15. That's why I don't think they would ever give you a question about a normal line, because it's just not that difficult if you know the tangent line. But you just use that slope now and the same point, which I think was -1, -10. So that would be y plus 10 equals -1/15 times x plus 1. And this is where point slope form is great, because you don't have to distribute that -1/15 and simplify all that. Yeah. Normal lines, usually people forget normal lines. I used to use practice exams from that were just a AP review book, and they weren't real exams, and they always put normal lines in there. People forgot them, but I don't think they did them. So we'll move on past that. Not drag down. Go. We have too much to do. Implicit differentiation. That shows up as well, and I think the tricky part about implicit is the directions don't say, hey, use implicit differentiation. You have to remember that if you cannot get y by itself so that you can just take the derivative of the x's, you have to use implicit differentiation. And again, it's usually a question that shows up on the no calculator multiple choice. There has been a couple in the free response section every now and again for one part of it. But remember that whenever you take the derivative of y, you put dy dx. It's kind of like the chain rule, and then you get all the dy dx's together and you solve for it. So the question on your test would just look like this. Find the derivative of this. And hopefully you would look at that and you would be like, how do I do the derivative with x's and y's? And then I hope that little light bulb comes on and you say, oh yeah, It's the dy dx stuff, even if you don't remember that it's called implicit. I'll tell you that on the 2012 exam, there's one question that's this. Actually, they ask you to find the second derivative of this. Not this exact problem, but implicit, and you have to do implicit twice. And I think I did that problem 7 times before I got it right, because I just kept making stupid little subtraction errors, and I was so annoyed. And I was like, if this was a real test, I would have just given up at this point and just guessed. But I finally got it. So when we take that one, I'll hope that you get it right, and you can be like, seriously, that wasn't that hard. And I can feel like a fool. But if I'm going to take the derivative of this, I'm just going to go through. The derivative of 4x is 4. The derivative of x times y, you have to do the product rule, and anytime you take the derivative of y, you put dy dx. So the derivative of x is 1 times y, plus, leave the x alone, and the derivative of y is just 1, but we put dy dx. Do you have memories of this? The product rule is usually what gets people, because they forget about that. But then this one, the derivative of negative 3y squared is just going to be negative 6y, but then we have to put dy dx. And remember that the derivative of 6 is 0. I think the first time I missed the problem was because I just wrote 6 there instead of 0, or whatever the problem happened to be. And then we just need to solve for dy dx. So I'm going to kind of do this all in one step, and you tell me if you remember or not. I'm going to move this to the other side, and I'm going to factor the dy dx out of what has dy dx. So that would be x minus 6y equals negative 4 minus y. And then you just divide that over, and you get negative 4 minus y divided by x minus 6y. And you got to be really careful with negatives, because obviously you could take a negative out of the top and you could put it through the bottom, and so sometimes you just have to match up the multiple choice, because, you know, fractions can be written a lot differently. I didn't put this on here, but I could ask you to find the value of the derivative at the point 2, 3. So find value. Remember, if there's x's and y's in your derivative, normally when we find a derivative, we just plug x in, because x is all that's in the derivative. But if there's x's and y's in it, you have to plug in both x and y, which is why they always give you both points there. What? Yeah, I just made it up. So if we plug y in there, that would be negative 4 minus 3, and that would be 2 minus 6 times 3 is 18. That would be negative 7 over negative 16. So we can still find the slope when there's x's and y's. You just have to plug in both the x and the y. And again, it's been a long time since we did that, and so it's one of those things that hopefully on the next test that we take, which I'm giving you a new take-home test this Friday, and it'll be due next Friday. So you'll have a week to work on it, which means you won't have as much, like, we've been having kind of homework every night over this review, but when I give you that test on Friday, that will kind of be your homework for the most part every day of just working on it to get it done. Yes. Okay, sorry.
I did.
Inverse functions and derivatives, this is another one of those things that we talked about one part of one day, and it's one of those rules that show up, and it's usually 1 or 2 questions on the whole test, and if you just know the rule, you'll get those questions right. If you don't, it's not a big deal, it's just 1 or 2 questions, but I like to review it with you. A function's inverse will have a derivative that's the reciprocal of the derivative of the original one. It's kind of, I really struggle writing this. And I wrote, remember that you can just switch x and y and solve back for y if you want to find the inverse. Almost always on the AP test, they don't actually give you the function. They just give you some points and a derivative value, and they want you to just know like how to do the reciprocal of it. And we'll find one that's on a real test. I tried to write this out here. I don't even know if I did this correctly. But I put f of x contains the point 2, 1, and the derivative at 2 equals 3. Find the derivative of its inverse function at 1. And I didn't put any extra information, but they tend to do that in the problem because they want to confuse you. But if the point 2, 1 is on f of x, so if f of x contains the point 2, 1, do you agree that the inverse has to contain the point 1, 2? Like that's the definition of inverses. switch. So notice that I'm asking you to find the derivative at 1, and you might say, well, how can I find the derivative at 1 when they give me the derivative at 2? Well, it's because you have to switch the x and the y. So the derivative at 1, I struggle writing this. Where do I write this prime? The derivative, I don't know how to write the derivative of an inverse function, will equal the reciprocal, so 1 over the derivative at the x point in the original problem. Which means the answer to this is just 1/3.
I'm sorry, how did you even do that?
This equation, this is just the rule. Like, this is the part that I want you to know. That's what I tried to write up here, but I struggled. A function's inverse will have a derivative that is the reciprocal of the derivative at that point. I feel like I don't know how to write all those words in there.
I get that, but why did we use f prime 2?
Oh, because they switch, right? If x is 2 in the first one, then the derivative of the inverse has to be the one at 1 because they switch. And a lot of times on the test, they'll give you some extra information. They'll say like f prime of 1 equals 7. And they're hoping, I don't know that they hope that you get it wrong, but I always feel like the people that write these hope that you get the wrong answer. Because they give you that extra information because they know that some people are going to say, oh, the inverse is just the reciprocal of this one, and you're going to pick 1/7. 1/7 would be a choice. But you have to know you have to switch the x and the y. So the derivative of its inverse at 1 is the reciprocal of what the original x value was. So you have to kind of match those up. And so that's why it's 1/3. And we're going to look, there's always 1 on the multiple choice, and we'll kind of go through it. I'm sure we'll find it on the 2003 one. And I'm not good at making these up because I don't know what odd information to give you. But it's always just the reciprocal. And so that's just the little extra fact that we have to remember. Okay? Oh my goodness, look at the time. I don't know that I really need to go through all this with you, but it's just kind of a nice review that gives you a summary of all those rules for derivatives. And I know you kind of remember them all, but it's easy to get them mixed up. But remember that critical numbers are where your derivative is 0 or undefined, and those are your possible values for max and min. I put where relative extreme might occur. Maybe we should put could occur. Because remember that just because it's a critical point doesn't always mean that it necessarily is a max or a min. And for the most part, to test these, we're going to use the first derivative test. There's other ways to test, second derivative test. But for the most part, first derivative test is what we like. It's because we learned it first. We did it the most. And that tells us increasing and decreasing. Remember that where your derivative is positive is increasing, where your derivative is negative is decreasing, and where your derivative equals 0 means it has a slope of 0 or it's constant. And when we find our critical points, that's where we usually make the little test intervals to do this. Like if we found that our critical points were like x equals -2 and x equals 4, then we would usually do something like this, and we plug into the derivative to see if it's positive or negative, and we'd be like, oh, this is positive, this is negative, this is positive, and we would say, oh, that means this is increasing to decreasing, so that must be a relative max. This is decreasing to increasing, so that must be a relative min. And I just want to point out that that's exactly how we do it. That's how I taught you to do it. But if they ask you to explain or justify your answer, this is not acceptable justification. Like, you actually have to write out what this means. You have to say, at -2, there is a relative maximum because the derivative changes from positive to negative, or the function changes from increasing to decreasing at that point. And if you don't write that out, they don't give you points for sign charts, which is ridiculous because we all know what that means. Math people knows what that means. But if they ask you to explain or justify, you have to actually write it out. And that's something that the more you practice it, the better you get at explaining your answer, because you know now to actually write it out. And so either one's okay. You can actually talk about the derivative changing from positive to negative, or you can talk about the actual function changing from increasing to decreasing, and that would give you your points there. And there's usually always something like that on the free response. That's what I just said. I took this from an email once about make sure your students know what's being asked. It says if they ask you for just an x value, right? We know we just to give it x value. If they ask you for the extreme value, that's the y value. So that if they ask you for actually what is the maximum, what is the minimum, that's the y value. If they ask you for the whole point, make sure you give the whole point. Derivative is 0 or undefined. Oh yeah, we know that. That's why critical points can be where it's undefined, because you have to look for where it's changing. But just make sure you don't miss a point. Like, it's one of those things that's just annoying when you miss it. It's annoying for me when you miss it. It's annoying when I miss it. When you give me an answer like this and they want an answer like this, like, that's just a silly thing that you got to make sure that you finish the problem.
But if they were just asking for either X or Y, would you put both?
I would think you would get the points. I can't say for 100%. I would give you the point because you just gave extra information. So I don't think that they'll penalize you for extra information. But if they ask for the whole point and you only gave the X, or what happens a lot is they ask you for the actual maximum, so they want the Y value, and you only give the X value. And so you just want to make sure that you answer it. So maybe if you just give the whole point, that might be. Sometimes you don't have enough information to give the Y value, which is why they ask for the X value. This is really not required. Oh, no, just kidding. No, don't write that. That's the second derivative test. Sorry. Down here, second derivative test is not required. That's what I was going to say here. I thought that's what I had here. And because the second derivative test does exactly what the first derivative test does, it's just another way to do it. So if you understand the first derivative test and you're good at finding your critical points and setting them, I honestly don't think I've ever done the second derivative test on the AP test. I could, but I just don't think of it. Like, I always just find my first derivative and set them equal to 0. But the second derivative test is a way you can use the second derivative to find maxes and mins. But I think kind of it's a good idea to just work with the first derivative test. And for the second derivative, know that that tests for concavity. Concave up and concave down. If it's positive, it's concave up. If it's negative, it's concave down. Remember that inflection points, we talked about this in 4th hour yesterday, these are possible inflection points because not every place, just like critical points, just because it equals 0 doesn't mean that it's automatically an inflection point. You have to check. So just like critical points, if you find your inflection points to possibly be at -2 and 7, you have to plug into the second derivative and see what happens. If it's positive, negative, negative, this one changes from concave up to concave down, so that would be an inflection point. But this would not be an inflection point because it stays concave down the whole time. And the same thing implies about the graphs, and we're going to talk about those tomorrow, I think. If they give you the graph of the second derivative, then they're going to tell you about the concavity. We'll talk about that more tomorrow. Not all on this page, so yeah, we're going to kind of maybe just X that out. We decided last year. And then velocity acceleration. We've talked about this very recently, and so I hope that maybe you remember this stuff. But again, if you took that first test and you actually read all the questions, you see that velocity acceleration position definitely shows up on that test a lot. And so just remember that you can tell where a function is moving right, left, or stop by using the critical points, just like number 1 on your chapter 7 test. You can find the ending position or total distance traveled. You can find how high it went or the ending position. Remember that acceleration is the derivative of velocity or the second derivative of the position function. I don't think I really have. Oh, is that it? Oh my God. Let me go really fast because I'm stressed. So I know I kind of rushed that a lot, but I'm just trying to, again, give you some smaller notes instead of having to go back through all the notes we've taken all year of really super important stuff. What I do have for you today is a decent amount of homework. That's exciting, right? This is from it says final exam at the top. This is from the calculus, the Idiot's Guide to Calculus. I crossed out a few of them, but 28, 29, 30, all those there, 31, 32, 33, 36, 37, 39, and 40. I want you to work those out tonight. I did them all on a separate sheet of paper. Definitely I would recommend doing it on the actual piece of notebook paper. The first 28, that's just reviewing your derivative rules. Regular derivatives, then just kind of seeing where we are. Look at number 37. He calls those sign charts that we do a wiggle graph, so I crossed that out and put first during the test because a wiggle graph, you can tell it's idiots guys calculus when they call it a wiggle graph. That's right. So try these and we'll see where we go from there. And we'll see how far we get into what our fake. Be convinced to give you a break on making you AP stuff today and give you a
Where does wiggle graph even come from?
I don't know. I think because you're looking, I don't know. I've never read the book all the way to see when it comes from. What?
Huh?
Oh yeah, you're taking a test. Okay, don't forget about test corrections and the retake. If you do your test corrections and you understand how to do area and disc and washer method, I really recommend taking the retest because there's only 4 questions in the retest, and it's all area, disc, washer. There's not even any velocity stuff on it like the first one.
No, I still don't really want to put time.
Only when you're finding volume or rotating it around the XY axis. If it just says find the area, you don't put pi. And you're not using a square or something else. If it just says find the volume, if you rotate around this, if it just says that, that's when you put pi. But you don't put pi that says find the volume of each one in the square. But I don't think that's what every test. So we need to figure that out before the AP test. But that's not here. Where's my wiggle graph? Trying to find a wiggle graph. Wiggle graph. Because this is the complete idiots guide, not calculus for dummies. Calculus for dummies is yellow. I call it calculus for dummies, but it's like it's called a wiggle graph because it tells you which way the graph is wiggling. I almost said that, but I was like, surely that's not. It's called a wiggle graph, and it tells you which way the graph is wiggling or increasing or decreasing. Oh, I'm still going.